In this session, we will learn about Kirchhoff's voltage law and voltage division rule. So we will start with Kirchhoff's voltage law. Kirchhoff's voltage law or KVL states that in a closed loop, algebraic sum of all voltages is equal to 0. In other words, KVL can be explained as in a closed loop, sum of voltage drops in various elements is equal to sum of voltage sources in that closed path. Kirchhoff's voltage law is also called as law of conservation of electrical energy. To apply KVL in a loop, select the direction of loop current either in the clockwise or in the anti-clockwise direction. Let the direction of loop current is clockwise. Mark the polarity of voltages across each element. Consider each term separately in the direction of current flow. For a voltage term, if current flows from positive potential to negative potential, that should be considered as negative, else positive. Find the algebraic sum of all voltage terms in the loop, which must be equal to 0. Mathematical representation of KVL. Let us consider a simple loop with n number of resistors connected in series with a voltage source Vs. Resistors are denoted as R1, R2, R3, Rn. Direction of current flow is chosen as clockwise. R1 is connected between points A and B, R2 is connected between points B and C, and Rn is connected between points D and E. Voltage source Vs is connected between A and E. First step, assign direction of current flow. Assume the direction of current flow as clockwise. Mark polarity of voltage drop across each element. Mark voltage drop across resistors and other elements with proper polarity. With wrong polarity, you will not be able to verify KVL. The polarity must match with the direction of current flow, and current always flows from higher potential to lower potential. So here, look at the polarity of voltage drop across resistance R1. The polarity of VR1 is given as B is more positive than A. But look at the direction of current flow. Current always flows from higher potential to lower potential if the element is a passive element like a resistor. So here the direction of voltage drop across resistance R1 is wrong. But direction of voltage drop across resistance R2 and Rn are correct, as the directions are marked as point B positive with respect to point C in the case of R2 and point D positive with respect to point E in the case of resistance Rn. Now write loop equation. When voltage drop across resistors are considered, these terms must be taken as negative, moving from positive potential to negative potential. And voltage source in this case must be taken as positive, as we are moving from negative potential to positive potential. Through voltage source Vs, current flows from negative potential to positive potential. Now applying KVL for this loop. So Vs minus VR1 minus VR2 minus VR3 minus Vrn is equal to 0. Rearranging the terms. Vs minus VR1 plus VR2 plus etc. plus Vrn is equal to 0 means that Vs is equal to VR1 plus VR2 plus VR3 plus Vrn. and this is KVL. Now let us apply KVL to find voltage drop across an element in a loop, that is voltage division rule. So voltage division rule is the application of KVL. Voltage division rule states that in a loop with a voltage source Vs and n number of resistors R1 to Rn connected in series, voltage drop across a resistor is directly proportional to the resistance value of that resistor. So VRK is equal to Vs into Rk, the whole divided by R1 plus R2 plus R3 plus etc. plus Rk. Consider the loop which consists of just 3 elements, one voltage source and 2 resistors R1 and R2. According to KVL, we can write Vs is equal to VR1 plus VR2. And according to Ohm's law, we can write VR1 is equal to Is into R1 and VR2 is equal to Is into R2. So KVL can be rewritten as Vs is equal to Is into R1 plus Is into R2. So Vs is equal to Is into R1 plus R2, as Is is a common term. So we can write Is is equal to Vs divided by R1 plus R2. So current flow through the loop is given as Is is equal to Vs divided by R1 plus R2. So according to Ohm's law, we can write VR1 is equal to Is into R1 and VR2 is equal to Is into R2. Loop current is given as Is is equal to Vs divided by R1 plus R2. Therefore, we can write VR1 is equal to Vs divided by R1 plus R2 into R1. We can rewrite VR1 as VR1 is equal to Vs into R1, the whole divided by R1 plus R2. Similarly, we can write VR2 is equal to Vs into R2, the whole divided by R1 plus R2. Now let us generalize this. A network consists of n number of resistors and voltage source connected in series. The resistors are denoted as R1, R2, R3, Rn, and voltage source is denoted as Vs. So according to KVL, we can write Vs is equal to VR1 plus VR2 plus VR3 plus etc. plus Vrn. According to Ohm's law, we can write Vs is equal to Is into R1 plus Is into R2 plus Is into R3 plus etc. plus Is into Rn, as same current flows through all the n number of resistors. So Vs is equal to Is into R1 plus R2 plus R3 plus etc. plus Rn. Or we can write loop current Is is equal to Vs divided by R1 plus R2 plus R3 plus etc. plus Rk. So in a loop with n number of resistors excited with a voltage source Vs, voltage drop across a resistor Rk is directly proportional to current flow through that resistance and is given as Vrk is equal to Vs into Rk, the whole divided by R1 plus R2 plus R3 plus etc. plus Rk. So this is voltage division rule. Thanks for watching Circuits Analytica. Enjoy learning.